You're standing in front of the graph. Okay, go.
Alright, so the last actual problem from the book that we're going to do is problem 34. So the problem actually shows you this graph right here, and we'll get to that in a second. So, problem 34. The function f of x is represented in the graph below. Draw a graph of its inverse. Be sure to state the domain and range for both f of x and f to the negative first of x. What is the relationship between the domain and range of the original function and the domain and range of the inverse? Okay, so the first thing we have to do is graph the inverse of this function. And how I'm going to do that is I'm going to take the points from this graph and flip them so that x becomes y and y becomes x. But first I have to know what these points are. So, for f of x, x, y. So our first point here is at -2, -3. So, and then this point is at 0, -2. This point is 1, 0. This one is 2, 2. And this last one is at 3, or is at 5, 3. Okay, so these are all the points for the original graph. Now, to find the points for the inverse, we are going to flip these points. So for f -1 of x, x, y. So for this first point, this -3 would become x. So it would be -3, -2, -2, 0, 0, 1, 2, 2, and 3, and 5. And so these are the points for our new graph, which would be the inverse. And now I'm going to graph the inverse. So we have to go out to -3 this time. Can't see that. That doesn't work. So -3, -2. So over 3 and down 2. So we have that point right there. And then -2, 0 would be here on the x-axis. And then 0, 1 would be up here on the y-axis. And then we have this same point, 2, 2. So the graphs are going to intersect at 2, 2. And then we have to go 1, 2, 3, and up 5. Alright, so over 3, up 5. And those are the points for our new graph, and now we have to connect them. Alright, so the original graph is here in orange, and these are its points, and the inverse is here in red with its points. And you can see that when you graph both, it's a perfect reflection, or it would be on graph paper, over the line y equals x. And so now for the last part of the problem, we have to compare the domain and range for f of x and f to the -1 of x. So the domain for f of x, which would be like the maximum x values, how far on the x-axis it can go. So I'm going to do this over here. So for f of x d, or domain, so the domain for the original graph only goes to -2. So x has to be greater than -2, but less than 5. Well, greater than or equal to. Well, x has to be greater than or equal to 5. Ah, fuck me.